This is part 2 of the caffeine experiment that we did in class. The next experimental, we started out talking about comparison and then about random assignment, both of which are essential in an experiment. And the next essential element is replication. That means we need to have an adequate number of experimental units in each treatment group so that the two groups are equivalent as possible. So let's just say, for example, that I only had 4 students in my experiment. 3 of the students were 3 girls on the soccer team, and they were all fairly small girls. And the 4th one was a very tall boy who was not involved in sports at all. Maybe more of a drama guy or something. And so no matter how I randomly divided the groups, I was going to end up with 2 small athletic girls in one group and 1 small athletic girl and a large non-athletic boy in the other group. So the individual differences in the groups were going to be so distinctly different that I couldn't say that the 2 groups were equivalent other than one had caffeine and one didn't. But if I had 20 people in each group instead of 2 in each group, even if there were some dramatic individual differences, there probably were enough similarities in the group that would overcome that problem. So it turned out in this particular experiment, I only had about 4 or 5 in each group, so we really probably didn't have enough replication to really get good results in this particular time. Replication could also refer to repeating the entire experiment with a completely different group of people, and we do that so that we can maybe apply the results of our experiment to some broader population. The 4th element that we want to discuss is control. Control means that we keep any other variables other than caffeine as much alike as possible. Of course, they have to be known variables. Sometimes we'll have unknown variables or variables we can't control, but these are variables we can control. So some of the things that I did to control were to make sure that everybody took their pulse rate exactly the same way. At the same time, we all timed our pulse rate for 30 minutes, or 30 seconds, then multiplied by 2 to get pulse rate for the minute. And then we waited the same amount of time. While we were waiting, everybody had to stay seated and not get up and down, so their pulse rate would stay as steady as possible, except for the caffeine. And then we all took our pulse rate again after a certain interval of time at the same time. Another thing that was really important, and so those were all examples that I did to reduce variability. But there are another important thing to reduce variability, so I'm kind of going to the second one first here, is to make sure everybody drank exactly the same amount. So I poured all of the beverages into identical cups, filled them the same amount, and told everybody to drink the entire cup. So that was another thing I kept the same. So there wouldn't be any variability in the results due to that kind of thing. The other thing that's important is sometimes if you don't control a variable, you can inadvertently get some confounding that maybe you didn't intend to do. So for example, I had to kind of look hard to find caffeine and non-caffeine drinks that both had sugar in them, that were the same type of drink, that had both sugar. So I found Pepsi with caffeine and Pepsi without caffeine that were both, neither were diet. Because if one were diet and the other were regular, then I would have the variable sugar confounded with the variable caffeine, because people who had caffeine also had sugar. People who did not have caffeine would also not have sugar. So I wouldn't know whether it was the sugar or the caffeine that was actually influencing the difference in pulse rates, if there was a difference observed. So those are some reasons to have control variables, to help prevent confounding by that controlled variable or to reduce variability. An example here of reducing variability is on the left-hand side. These are the results of someone doing the experiment where everybody drank exactly the same amount of either non-caffeinated or caffeinated soda. You can see a distinct difference in the change in their pulse rates with the caffeine having a higher change. In the second group, one group drank caffeine and the other did not drink caffeine, but they were allowed to drink as much caffeine, much of the drink as they wanted to. So people drank varying amounts of caffeine, had varying results as far as change in their pulse rate. We see a lot more variability in the results. Therefore, the difference in the results is less conclusive. Now, it turns out in our results that they weren't conclusive at all. We ended up with in the caffeine group, somebody having a pulse rate that went down by 10 and one that went up by 10, and then one that stayed the same, and then a couple of that went up a little, and then we had similar differences in the non-caffeinated group. And I think I can figure out what the problem was. I think the main problem was we had one student who had to leave early for a dentist appointment. So in order to include him in the experiment, we took our pulse rate, initial pulse rate at the very beginning of class. We had one student who had just come from running 2 miles in gym class, so he had a very elevated pulse rate. We had people who had just gotten to class, other people who had been sitting for a while, all different. And so people's weren't all at their resting pulse rate. So some people's pulse rate went down because it had been elevated at the beginning of the class for some other reason, and despite the caffeine or the not caffeine, it was going to go down. And then we had, I don't have any idea why this person's pulse rate went up, even though they didn't drink caffeine, but the individual differences plus the not doing the lack of replication plus not waiting to take our pulse rates after everybody was having a resting pulse rate, I think kind of messed up our results.